In this video, I'm going to look at operations on functions, but I'm going to look at how to perform those operations just using the graphs of the functions. So we're going to need a grid. Let's say we have two functions. I'll make them functions you know. F at x plus, let's say, 2x minus 1, so a nice linear function. And g at x will be, let's go with a quadratic function. Let's go with negative x squared plus 1. Okay, and we're going to want to graph. Let's go with first one will be f plus g at x. So we want to graph the function f plus g. So the first thing you're going to do is graph f and g separately. You're going to want to take care to be as accurate as possible. So that's why I've got a grid. I didn't just do it by hand. So I have a y-intercept. I'm going to assume the scale's 1s. So my y-intercept is negative 1. My rise is up 2 over 1, up 2 over 1. So you want to be specific about as many points as possible. That should be sufficient. And then 2 down here. And then I have a line going through these points. And again, you can't put a ruler on the computer screen, so I apologize for the crookedness of this line, but you do what you can. Maybe I'll use a different color. I'll use blue for G. So we've got a parabola now. Vertex is at 0, 1. So I'm trusting you know how to graph parabolas. If you don't, I believe I have a video on graphing parabolas, so you can go back and check how to do that if you don't remember. But we always start with the vertex, and then you have to sort of know the pattern for the rest of the points. Missing. Alright, so this is the two functions. Now in red, I'm going to do f plus g. Okay, so what you're going to do is basically go point by point. Remember that f plus g, maybe I'll rewrite this here. So f plus g at x is equal to f at x plus g at x. So basically we're going to have to think about different points. So let's say when x is 0, f plus g at 0 is equal to f at 0 plus g at 0. I don't know if that fit on the screen there. So what you're going to have to do is, well, what is f at 0? F at 0 was the black one at 0, so that was negative 1. And g at 0, that was 1. So we have negative 1 plus 1 equal to 0. So our new function at 0 will be equal to 0. So it's going to go right through the origin. Another way to do that, if just by looking at the graph, you're not going to want to write this out for every point, although you could if you wanted. You're going to take, okay, what's the y value here? 1. What's the y value here? So they're right above each other. They're the x equals 0 points. Negative 1. So 1 plus negative 1 is equal to 0, so I'm right there. Let's go to x equals 2. So here we have the height here is 3, right? Y equals 3. The height here is negative 3. So we have 3 plus negative 3. So again, we're at 0. So these two red points are on my graph. Now you can go to this one. Here we have 1. So for x equals 1, the y is 1 for the black function and 0 for the blue function. So 1 plus 0 is 1, so we're going to be at this point here. Now we'll do this point. So here we're up at 2, 3, 4, 5. So we have 5. Then below that we have, let's see, 1, 2, 3, 4, 5, 6, 7, negative 8. So 5 plus negative 8 is negative 3. So that would be this function, this point here. We'll do this point. 0 plus negative 3 is negative 3. So that might be enough to kind of see what's going on. We've got a function doing this, if I connect these points, which looks like it's a parabola. And if we were to write the equation for f plus g, I'll write it over here. F I don't want that bracket. Well, f plus g at x was equal to f at x plus g at x. So if I wanted to write the equation for that, I would have been writing f was 2x minus 1 plus, so that's f, g, which was minus x squared plus 1. Well, if I collect like terms and add them, then I have minus x squared plus 2x minus 1 plus 1 is 0, so I have this equation. Well, that's a quadratic equation. That's a parabola opening down, which is exactly what I have in my graph. So that's how you add two functions graphically. You just kind of go point by point, adding the same x values. Right? If x is the same, then you add the two y values together. You could do the same for the difference. You could do the same for the product. You could do the same for the quotient. Okay, here's two more functions, and this time we're going to graph f minus g at x. So they're both square root functions, so you need to know the base square root function, right? Something like that. So x plus 2 is a base square root function shifted over 2. So it's going to go through this point, through this point, through this point, 7, and through this point. And it's going to look something like that. Not quite as crooked there, but you know, that's f. So here we have f at x. In blue I'll do this one. So this one, there's a negative in front of x, so it's going to be rotated in the y-axis, or reflected in the y-axis, and shifted 5 to the right. So right there, right there, right there, and it's negative 4. Right there. Oh, that's not nice. So something like that. So that would be g at x. And now we just want to do the same thing where we add kind of, or in this case subtract, vertically. What's going to make this one a little bit trickier is the nice sort of y values do not line up in this case. Right? In this case, so remember we're doing the black one minus the blue one. So here we have a y value of 0, and here, right, the same x values, we have a y value of not quite 3, but I don't know exactly what it is, so I'm going to have to be I'm very loosely estimating. Right? So I have 0 minus 2 and a bunch, right? 2, somewhere between 2 and 3, a little closer to 3. So that's going to be the negative of whatever this number is. So I'm going to plot that sort of right around there. For this one, I have 1 minus 2 and a little bit less than this. So 1 minus 2 and a little bit less than that would be 1 and a little bit less than that. So it's going to be something like something there. Let me go over to, well, I'll keep going. So this is 1 and a bit minus 2 and a bit, which is around negative 1. What do we got here? 1 and a bit minus almost 2. So it's just the difference. So it's going to be close to there. Here now the black function is bigger than the blue function. So we've got 2 minus 1 and a bit. So that's just going to be the difference. How far apart are they? So not very far apart. So put it there. Here we've got 2 and a bit minus 1. So it's going to be 1 unit lower than this. And here we have this value minus 0. So we're going right through that value. So we end up with a function looking something like this. And now notice, I mean, it looks kind of like a straight line. I don't think it's quite a straight line. But notice that I stop here and I start here and I don't go any further. And the reason is, remember, the domain of this red function is only the overlap of the domain of the black and the blue functions. So the black function starts here, or that's its boundary, right? Doesn't have any values over here, so the red function won't have any values over here. Same with the blue one stops here, or doesn't have any values here, so the red one won't. It will only exist sort of in between where the black and the blue one both exist. So you only get this little bit of a function here.